if you would like to, okay, remove a node from heap. Okay, so as mentioned, we would like to have the node maximum value to be removed, right? Okay, so we call it remove max. Okay, after removal of root, then we perform an operation that is what we call max HeapPQ. Okay, max HeapPQ. So it means that we would like to move this 8, okay, along the tree, and it will start with the root first. Okay, put it as the front. So that is the operation of HeapPQ. Okay, now you understand the idea first. Okay, you would like to remove the first one. Okay, therefore the first line is pop, self heap pop. Okay, that is the maximum element is popped. Okay, put it as pop. Okay, so it will be returned. But after getting the value, it has to be heapified. And you can see that the line, this statement, okay, this heap dot front is equal to the heap size dot size. It means that this size, okay, is moved to the front, right, to replace this 20. This 20 is already put as the value of the port, right, that is to be returned. And then the size is reduced by 1 here, and then perform the max heapification. And then what it did, again, when it doing the heapifying, it would start with the root, right? It is the first one. So it would go down, okay, go down by changing the position of POS. Okay, it would down the tree. Okay, so it would try to compare the value. Okay, compare is left or right. Okay, if in case that, okay, the value is actually greater than is one of these children, then this student doesn't have to change, and it have to check with another one, right? So it would try to do the comparison, okay, one by one. So as for the logic, okay, if the leaf log is non-leaf and have similar than that of children, then it has to move, right? If it is greater than both of its children, then nothing to do, then it stopped. Okay, so it search until the leaf is fine. Okay, so you can see that these two modules is actually perform the case that. Now, first of all, this line is determine whether an action has to be done, right? That is, the node has to move down. If it need, okay, it would determine whether it should go with the left or go with the right. Okay, if we need to go to the left, okay, then this logic, you will know that, okay, about this logic is that first of all, when it comes to this line, it means that it need to go down. Okay, if it testifies that it has to go down because it is the search value. Okay, the newly it will be something like 8. The 8 is known to be, if it is true, that you know that it must be going down. It is either smaller than the left one or smaller than the right one. It must go down. So knowing that it has to go down, so it has to determine which way to go, left or right. So this statement is to determine whether it should go left or right. So if it is go left, it would do this. Okay, doing left. Okay, if it is to go right, so it would perform this one. Okay, going down. So it is the operation, okay, of the max heap and the heapifier.